Okay, today we're gonna do some examples of finding horizontal asymptotes. We just did some examples of finding vertical asymptotes. So vertical asymptotes aren't bad. You're just taking your denominator of your rational function and setting that equal to 0. And vertical asymptotes are wherever your denominator is equal to 0. Um, Horizontal asymptotes are a little bit more tricky. The first thing you have to do when you're finding a horizontal asymptote is figure out the degree of your polynomial on the numerator and your polynomial in the denominator. And then based on the degree of those polynomials, you will have some steps to take in order to find your horizontal asymptote. So just a quick review of degree. Degree is going to be the highest power of x. So for this first example up here, f of x equals 4x minus 8 divided by 2x squared plus x plus 10. The degree of our numerator polynomial is going to be the degree of 4x minus 8. So the highest power of x is 1 here. So the degree of the numerator is 1. Here, the degree of the denominator is going to be 2, because 2 is the highest power of x. So when I'm doing these problems, I normally like to kind of draw something like this, where I like to kind of draw out the degree. So the degree of my numerator is going to be 1, and then the degree of my denominator is going to be 2. So I'm going to do that for this next one here. The highest power of x I have on my numerator is going to be 5, so that's the degree of my numerator. Degree of my denominator is also 5. And I have a third example here. It's going to be this example right here, and I'm just going to find the degree for this as well. Looks like the degree of my numerator is going to be 2, and the degree of my denominator is going to be 1. So we have these three examples right here, and as it turns out, depending on the degree of your numerator and your denominator, you could have three different things. You can have a horizontal asymptote of y equals 0, which occurs when the degree of your numerator is smaller than the degree of your denominator. So for this first example right here, when the degree of your numerator is smaller than the degree of your denominator, no matter what, you don't have to do any more math. You know that your horizontal asymptote is going to be y equals 0. So that's your answer. Simple as that. So that's why when I'm doing these problems, the first thing I do is I just go through and I find all of the degrees of my numerators and denominators. And if I get lucky and the degree of my numerator is smaller than the degree of my denominator, like in this case, I just write y equals 0 for my horizontal asymptote and I'm done. So that leads us to the case where the degree of your numerator is the same as the degree of your denominator. So for this case, what you do is you take the coefficient on the highest power of x in your numerator and you divide it by the coefficient on the highest power of x in your denominator. So the coefficient on the highest power of x in my numerator is going to be this 10 right here, as the 10 is attached to the x to the 5th. And in the denominator, it's going to be this 5 here, because the 5 is attached to the x to the 5th in the denominator. And as long as my numerator and denominator have the same degree, I just take these two numbers out front and I divide them. So my horizontal asymptote is going to be y equals 10 over 5, or y equals 2. So if I look at the degree of my numerator and it is the same as the degree of my denominator, I still have a pretty simple procedure. I just need to to take my I just need to take my coefficients on my highest powers of x, and I need to divide the two, and then I'm done. So that's my horizontal asymptote for this example. So now that those two easy ones are out of the way, we still have one more case to go over, and that is what happens when the degree of your numerator is bigger than the degree of your denominator. So you see my highest power of x is 2 on the numerator versus highest power of x is 1 on the denominator. And this is the hard one. So when you look at your degrees and it turns out that the degree on top is bigger than the degree on bottom, you're going to have to do polynomial long division, and the result of that polynomial long division is going to be your horizontal asymptote. So I'm just going to set up polynomial long division and go through it. I have some videos on polynomial long division that kind of take this into a lot more detail, and I know that I do way more than one example of polynomial long division. I think I have like 3 videos where I do a bunch of polynomial long division. But I'll just go through it for this example. So this is how we're going to set up our polynomial long division. And pretty much if you have learned this before, you're going to put a number up here that multiplies to this x that makes 2x squared. So what times x gives me 2x squared? Well, that's going to be 2x. So 2x times x is going to be 2x squared. And then I'm also going to say 2x times negative 2 is going to be negative 4x. And then the way that I like to think about this operation here is that you're adding both of these together, but you're distributing a negative. So I have 2x squared plus a negative 2x is going to give me 0. So these two first terms are going to cancel, which is good. And then I have negative x plus, and I'm distributing this negative, so this negative distributed in here, and this negative is going to distribute in here and become positive. So I have negative x plus positive 4x, so that's going to give me a positive 3x. And then I just bring my 3 down, and I have a negative 3. So now I need to put a number up top here that is going to multiply to x and give me 3x. So that's going to be plus 3. So I take my 3 and I multiply it by my x and I get 3x. And I take my 3 and I multiply it by my negative 2 and I'm going to get negative 6. And then we're just going to repeat this process over again. And once again, I'm going to add these two together and distribute the negative. So I distribute like this. And it looks like I'm going to have 3x plus a negative 3x, which gives me 0. And then negative 3 plus a positive 6 is going to give me a positive 3. And there's nothing that we can multiply by x to get 3. So we know that at this point we're done with our polynomial long division, and our remainder is going to be 3. So for this, your remainder actually doesn't matter. So this last step we actually didn't really have to do. I just did it for completeness, but you can just kind of throw your remainder out. It's not super important, but what really matters is your quotient up here. 2x plus 3, that's going to be your horizontal asymptote. So your horizontal asymptote is going to be y equals 2x plus 3. So hopefully that wasn't too bad. Once again, it's just kind of looking at the degree of your numerator, looking at the degree of your denominator, and then based on the comparison of those two numbers, you're either going to just have a horizontal asymptote of y equals 0, or you might have to do polynomial long division, or you might have to just divide two numbers. So, yep, hopefully that wasn't too bad.